Hello, students. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugwabela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 still on analytical geometry. And then this video here, or this question here, is compatible with both grade 11 and grade 12. So feel free to watch this video all the way up until the end and learn very quick and easy ways to deal with your analytical geometry. Let's get down to it. So they say the straight line AB has an equation 5y minus 3x minus 5 is equals to 0. Now, I need you to pay attention to this, right? A lot of people have the tendency of just assuming that our gradient here is -3, since they can see that, remember, we normally say that the gradient is the coefficient of x, right? But then one thing that we have to stress there is that the gradient is the coefficient of x if your equation is already in this form, the standard form. So when you have made your y the subject of the formula, and then now you have y is equals to mx plus c, that's when you can say the coefficient of x here is the gradient. But at this point, you can see that your equation here is not in standard form. So you can't say that your -3 there is the gradient, right? So that's the point that I want to make. Then another straight line CD is drawn to intersect AB at P, 5:4, such that the acute angle between AB and CD is 45 degrees. Now, 5.1 says determine the gradient of line CD. Remember, there are two ways in which we discussed to find the gradient. We said number one is whereby you just use the gradient formula, but then you can only use this approach if you have two sets of coordinates. So had I had the coordinates of C and the coordinates of D, then that's the formula I would go for. And then that wouldn't be 5 marks, obviously. Now, what's another way if we can't achieve it with this one? We know that we have to use the angle of inclination. So looking at those straight lines there, you can see that they're forming an angle of inclination, with alpha here being the angle of inclination of line AB. So our alpha there. Now, tan theta is equal to m. That's the formula for the angle of inclination from your formula sheet. Then obviously, if we cannot achieve finding the gradient using this one, then the other option is by the angle of inclination. But then the challenge that we have again is that we do not have the angle of inclination for CD. But then remember, this is analytical geometry, right? So that means we can just go there and assume and just put it there, not assume in a way, but then just put our angle of inclination there, because we know that the angle of inclination always occurs between the positive x-axis and then going anti-clockwise to touch the line in question, right? So the line in question is CD, line CD. So in order to form our angle of inclination from the positive x-axis all the way to touch line CD, and then we can say our angle of inclination is theta. So now we will say, let's assume that theta is the angle of inclination of CD. And then alpha here is the angle of inclination of AB, right? Now, this is always the question that always pops up when it comes to this, right? Most of the time, you will have to end up using this theorem here, whereby you say that the exterior angle of a triangle is equal to the two opposite interior angles. So most of the time, these questions always boils down to this theorem here, whereby we say the exterior angle of a triangle is equal to the two opposite interior angles of a triangle, right? So as we can see here, if we can manage to find the angle of theta here by doing what? By finding the other two opposite angles here, right? So remember that theta must be a sum of this angle here and that angle here. But then looking at this, we can almost tell that the angle in here needs to be 45 degrees because of what? Vertical opposite angles. So let's go ahead and just assume that this one here, this angle here, let's call it beta, right? For argument's sake, then let's call it beta. So that means our first point, let's just go beta will have to be equal to 45 degrees because of what? Vertical opposite angles. So, okay, that means the next challenge now is to find what will be the angle in here, right? What will be the angle there? So the angle there, we are already assigned alpha, so we have to calculate alpha. But how can we calculate that one? Remember, it's an angle of inclination, and the formula that we have for angle of inclination is that one. So, but then first, before we can calculate the angle of inclination, we need to figure out what is the gradient. And then we cannot come here again. Remember, I made you note that you cannot just come here and say your gradient is -3. The first thing that you'll have to do is make sure that this equation is in the form of y is equals to mx plus c. Then that means we go 5y minus 3x minus 5 is equals to 0. So that means that 5y is equals to 3x plus 5. And then if we divide throughout by 5, then that's equals to y is equals to 3 over 5x and then plus 1, right? Now at this point, that's where we can say that the coefficient of x here is the gradient. So therefore, the gradient of line AB needs to be equals to 3 over 5, right? So you see the difference now. For someone who could have said it's -3, they were already doomed for failure. Then, okay, so to calculate, we will say we know that our tan alpha using the angle of inclination will have to be 3 over 5, right? It's equals to the gradient. Then our alpha is tan and then 3 over 5 like that. So at this point, you need your calculator for that one. So to calculate our alpha, we find that our alpha is equals to 30.96 degrees, right? Okay, then, but then we are looking for the gradient of CD. Let's not get carried away. Then remember here we had 45, and then now we just found that that's 30.96. But then we just discovered this theorem here that says the exterior angle here needs to be equal to the two opposite interior angles. So that means our alpha is equals to 45 degrees plus 30.96 degrees. And our reason is exterior angle of triangle, right? Then what is our theta there? So that means our theta will have to be 75.96 degrees, which represents the angle of inclination. So the theta there is our angle of inclination. But then are we done? Remember, we are looking for the gradient. So now that we have the angle of inclination, we go back again. Tan theta will be equal to the gradient of line CD, right? Because that angle of inclination occurs between the positive x-axis and line CD. So that means that's tan 75.96 representing the gradient of CD. So the gradient of CD is equals to what? So if we punch that into our calculator, we find that it is equals to 4 rounded off, right? Then that's it. So that's how you were supposed to tackle that question. It was a very, very nice question. So make sure that you play this video as many times as possible and try to understand the approach that I took there. Okay, then 5.2, now they're saying hence or otherwise determine the equation of line CD. Right. Now, the hence part means that from whatever that you calculated in 5.2, from whatever conclusion that you made in 5.2, use that particular conclusion to carry on with the question. So we'll just look at it in terms of hence. I normally say hence is for those that actually see, and the otherwise is for those that don't see. Then, okay, so we have our gradient for CD is equals to 4. But then look at CD. It is passing through this point here. We don't have the coordinates for C. We don't have the coordinates of D. But then we do have the coordinates for P, which happens to be on the line CD, right? So that's a collinear point there, meaning that we can use that point because it lies on the line CD. So that means we want to go y minus y1 and then mx minus x1. So that's y minus 4. So we are using the coordinates of P. Then our gradient is 4, and then that's x minus 5. So we have y is equals to 4 times x is 4x. 4 times negative 5, that's negative 20. Then if we transpose the negative 4, that's plus 4. Then y is equals to 4x minus 16. Then just like that, you have your 2 marks, right? So remember, again, I stated that if you prefer this one, then you can even go for that formula there, where you just say 4 here, and then your gradient again is 4, but then your your x coordinate is 5. So that means you first find the coordinate of C. So that's 4, 20 here plus C. So your C has to be 4 minus 20, that's negative 16. And then you just write your formula as y is equals to 4x minus 16. So it's just a matter of preference and which one you understand better. But then either way, that's how you were supposed to find your equation. So that's how you were just supposed to tackle this question, all for a total of just 7 marks. So the only question that was a bit tricky is 5.1, but then once you understand the drill, then that's how it goes, right? So with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.